Friends, gases tell you what kind of fault is happening. Oil tests tell you how healthy the insulation is. But metal content analysis tells you something deeper. Which internal component is slowly wearing out? Copper, iron, aluminum, zinc. These metals should never be freely circulating in oil. When metals appear in oil, it means mechanical wear, corrosion, arcing damage, or insulation breakdown has already started. Most engineers look at metal results and say, values are small, ignore. Senior engineers never do. In today's Electroverse episode, we decode metal content analysis in transformer oil. Why metal analysis is not a routine test. Which metals indicate which internal component. IEC and ASTM test methods used. Why standards do not give fixed alarm limits. How trend and metal pattern reveals internal damage. And how metal analysis confirms failures before dismantling stay till the end. Because metals in oil are physical proof, not assumptions.
When we talk about transformer oil analysis, there's one critical test that many engineers overlook until it is too late: metal content analysis. This isn't just another routine check. It's your transformer's way of telling you exactly where internal damage is happening before catastrophic failure strikes. Think about it this way: when metals start appearing in oil, the transformer is telling you where it is hurting. Every metal particle dissolved in that oil represents physical damage occurring inside your equipment right now. And here's what makes this analysis so powerful. It doesn't just tell you something is wrong, it tells you exactly which internal component is being attacked. Metal content analysis measures dissolved and suspended metallic elements in transformer oil using sophisticated techniques like ICP-OES or ICP-MS. The analysis follows ASTM D5185 standards and is guided by IEC 60422. Results are reported in parts per million, giving you precise measurements of what's happening inside your transformer. But here's where it gets interesting. These metals don't just randomly appear in your oil. Each metal tells a specific story about what type of damage is occurring and where. Copper, iron, aluminum, lead. Each one points to different failure mechanisms happening inside your transformer. Let's start with copper. Copper in oil is never ignored. When you see copper levels rising, you're looking at one of the most serious warning signs in transformer diagnostics. Copper typically indicates corrosive sulfur attack or acid attack on windings and connections. Even small increases matter because copper doesn't dissolve easily under normal operating conditions. When it appears, something aggressive is happening to your winding materials. Iron tells a different story. Rising iron levels usually indicate core or tank corrosion or mechanical wear of internal components. You'll often see iron increases when oil condition is poor, with high acidity or moisture content, creating corrosive conditions. Iron can also indicate loose bolts, vibrating components, or mechanical stress on internal structures. Aluminum is particularly critical in aluminum-bound transformers. When aluminum appears in oil, it typically indicates conductor surface degradation, loose connections, or electrical erosion at contact points. In aluminum-bound units, rising aluminum levels often correlate with heating problems or poor electrical connections that are creating localized hotspots. Lead indicates chemical attack, age-related degradation of lead-containing components, or contamination from previous repairs. While many modern transformers use lead-free materials, older units still contain lead-based solders and components that can degrade over time. Now here's the crucial part that many engineers miss. There are no universal trip limits for metals. The interpretation isn't about hitting some magic number. It's about understanding trends, correlating with oil chemistry, and considering your specific transformer design. The key principle is this: trend is more important than absolute value. A transformer showing steady copper levels at 5 parts per million might be perfectly fine. Another transformer showing copper rising from 1 to 3 parts per million over 6 months could be heading for serious trouble. It's the rate of change and the correlation with other parameters that matters. This is where engineering judgment becomes critical. You need to correlate metal findings with oil chemistry results. High copper with rising acidity and moisture suggests active corrosive attack. High iron with normal oil chemistry might indicate mechanical wear rather than chemical corrosion. The story emerges when you look at all the data together. Consider your transformer design too. Oil-filled transformers with aluminum windings will have different baseline metal levels than copper-wound units. Older transformers with lead-based components will naturally show higher lead levels. OLTC transformers might show higher copper and silver from contact wear. Understanding your equipment helps you interpret the results correctly. Here's what makes metal analysis so valuable for predictive maintenance. Many catastrophic failures were preceded by rising copper levels, ignored metal trends, and focused only on dissolved gas analysis. Engineers who caught rising metal trends early were able to schedule maintenance, replace components, or plan replacements before failure occurred. When you see rising metal levels, you're looking at damage that's already happening. This isn't a prediction of future problems. It's confirmation that internal attack or wear is occurring right now. The question becomes how fast it's progressing and what you can do about it. If metal levels are high or rising rapidly, you need to take action. First, increase sampling frequency to understand the rate of change. Second, correlate with other oil tests, dissolved gas analysis, acidity, moisture, and oil quality parameters. Third, consider internal inspection if the transformer can be taken out of service. Fourth, evaluate loading and operating conditions that might be accelerating the damage. Remember this clearly. Oil chemistry shows conditions, metal analysis shows damage, and rising metals mean internal attack or wear is actively occurring. When metals appear, the transformer is bleeding internally. Each copper particle, every iron fragment, every aluminium trace is your transformer's way of communicating its internal condition. Listen to what it's telling you. Trend the data carefully and correlate with other diagnostic tools. Your transformer's health depends on understanding these metallic messengers floating in its oil.
So friends, this is the real meaning of metal content analysis. Metal analysis does not predict faults. It confirms internal damage mechanisms. Copper indicates conductor or winding issues. Iron indicates core, tank, or structural wear. Aluminum points to conductor or spacer degradation. Zinc and lead often come from coatings or solder. Remember these rules forever. Metals should be near zero in healthy oil. Sudden increase is more important than absolute value. Metal pattern matters more than single metal value. There are no universal alarm limits and standards, because every transformer design is different. That's why metal analysis is condition-driven, trend-based, and diagnosis-supporting. If this explanation helped you think like a condition monitoring specialist, then support Electroverse. Like this video. Comment below. Have you ever correlated metal rise with internal inspection? Subscribe. Because next we connect DGA plus metals plus oil tests into one diagnosis logic. You've been watching Electroverse, where every spark tells a story. Stay charged, stay safe, and happy.